In the second video, we are now focusing on wind power plants. It is very helpful to watch the first video because the structure is similar and we still need to go from a macro level more to a micro level. But in this case, now we stay in the network region of substation Mainz. And as you remember from the first video, this is a highly congested area, especially this line, because a lot of wind power plants are actually installed in this area. And there is a lot of curtailment happening. So in general, we also understood from the first video that it's not a good idea, most likely, to build even more wind power plants here. However, we have two options and we can also investigate what's actually happening again in this network region. One option is, of course, we have a lot of wind power plants and they are maybe already a little bit old. Like, let's have a look here. We could have identified this kind of park before, and we see, okay, it's commissioned 1999 actually. So most likely it's still in operation, but it's a good candidate for getting repowered at a certain point. And when we want to repower, we might want to increase also the installed power here per turbine, and this need to be feasible. So, but as you know from the first video, there's a lot of curtailment, which makes it tough. At the same time, there is still like new generation planned. So if we can switch again here to in planning, we can load plants and we see, okay, there is still like wind plant in this area here. And we also see it's like 5.7 megawatt. So how can this be possible? Most likely a reason why they are planned here is because there are grid extension plans, as we saw, which helps to get a little bit of relief in this area, because now the power flows are splitting up, not all over this line. It can also flow here and go down this way or go up here and more into the load centers here. So this is probably helping. This is why new power plants can also come here and are connected in the future. Another reason is that if we analyze the substation Büren, we see what is already connected. It's around 73 megawatt, but we also see that there are like two transformers and they total up to like 200 MVA. So, which makes sense to include here even more wind power because it's possible to connect them. As I said, a rule of thumb is that you do not want to exceed the capacitance of the total installed substations by around 65%. So there is still some margin left up to, let's say, 120 MVA of like additional generation that can be installed here. And apparently also this line is very congested. There is coming another line which will help to relieve in this area the power so that there is not that much curtailment anymore. So let's go back to what is already installed and not planned, because you can also understand better different grid locations if you investigate them closely as a wind power person. Let's have a look. So we load again the plants that are currently installed. Let's have a look here. This was a very old wind power plant. It belongs to a certain grid connection point, which we can see here. We can also actually look up who is the operator and who is the grid operator, but let's skip that. And we get a report in the grid location report We paste in here the grid location, we load it, we see it's 18.5 megawatt. We push apply, and a report is manufactured for us. And the report shows us how much curtailment and how much generation over the last in the year 2025 actually happened. So we see very fast what is installed. This corresponds to 1 per unit. We also see how much energy was generated, what is the curtailed energy, 6.09%, and how much it was curtailed with respect to the generation on this side. So it hit in 1 week nearly 50%. Here we have 35%. So this gives an idea of the risk if like such a project is acquired, of how difficult it might be to increase the capacity because there is already a lot of curtailment happening in such a wind park. So yeah, this is everything about wind. The other rules, as explained in video 1, can be applied to understand where it makes more sense to develop wind power plants when it comes to grid connection capacity.